Hello, General Biology. So we are still in Chapter 1. We're Section 1-2, and we're talking about scientific theories. And one of the things I wanted to add with this is a theory, a useful theory, has to be thoroughly tested. It has to support many lines of evidence in order for it to become a dominant view among scientists. But as I said, no theory is considered to be absolute truth. And again, we go back is in order for it to be valid, it must be able to be proven wrong. So we have the cell theory is one of the theories that we have, and we know so far that on Earth all living things are made up of cells. And we know on Earth cells come from pre-existing cells. And we know that cells are the basic structure and function of living things. But we haven't discovered everything yet. So it's still considered a theory, but it's a valid theory. And if it holds true and we can't prove it wrong, then we know that it's good. If we can prove it wrong, okay, so then we have to come up with something else. Maybe there's living things that are made out of plasma. So, that's something that we haven't discovered yet. So we can revise it and we can replace it for a more useful explanation if necessary. So now considering science and society, the two key concepts that we're going to see here is what is the relationship between science and society, and we're also going to use science to involve our understanding it in context in society and its limitations that we have. So, science and society. There's many questions that affect our lives that require scientific information to answer it, and many have inspired important research. But none of these questions can be answered by science alone. So scientific questions involve the society in which we live, our economy, and our laws and our moral principles. So in other words, everything that we do, even economically, even where our laws come from, and the principles that we hold, come from our scientific knowledge and our scientific understanding. One of the big things is environmental science. One of the classes I teach is AP Environmental Science, and when we think about what happens to the environment, if we have a healthy, thriving environment, then we have a healthy, thriving economy. They go hand in hand. If it wasn't for science, we wouldn't know how to have a healthy environment. We wouldn't understand all the biogeochemical cycles, a term we're going to be learning later on, and we wouldn't know the importance of organisms in their habitats, and our economy would be suffering. Take a look at Easter Island. If you're familiar with Easter Island, it's an island that is off of South America in the Pacific Ocean, and there's nobody living on it. There are signs that there was a very healthy population living there one time, but they depleted the island of all its natural resources because they didn't understand the impact that they were having. Well, science now knows that impact and could have taught them sustainable agriculture so that they could still survive. So science benefits society in those ways. One of the things we've also got to think of is the ethics and the morality. When scientists explain why something happens, sometimes their explanation only involves a natural phenomena. But pure science does not include ethical or moral viewpoints. So if we're able to do the first test tube baby, or we're able to clone Dolly the sheep, that's just pure science. We're not putting any ethics or morality into that. Biologists try to explain in scientific terms what life is and how it operates, but science cannot answer questions about why life exists or what the meaning of life is. Okay, so that's a moral, that's an ethical view people have. We can talk about abortion, and Catholic Church believes, and I believe, that right at conception, that's life. The minute that egg is fertilized by the sperm, that's life. That's an individual. But there's other schools of thought that feel no, that's not, and abortions are fine up until 3 months, or even some late-term abortions, because they don't think of that life as an independent life. But science can tell you that it has a complete set of chromosomes, and those chromosomes are going to be able to develop it into a living, sentient being. But it cannot tell you the morals or ethics or the values that you need to have about that. Science can tell us how technology and scientific knowledge can be applied, but not whether it should be applied in particular ways. So that is something that you have to morally and ethically make on your own. One of the things, too, that you need to do as a scientist is avoid any bias. Bias is kind of like a particular opinion, or you have a preference to that viewpoint. There are some people, I shouldn't say people, there are some scientists that will do research. Let's say I am a cigarette company, and I've hired a company to research whether cigarette smoking is healthy or not. And I'm paying this scientific research company millions of dollars to do this research. Well, if I'm a cigarette company and I'm paying them, then they might lean more to what I want them to say, and that is that, oh, no, it's not cancer causing, no problems when you smoke. And that would be biased. Where if an independent company hired the scientific research the research group, then they wouldn't feel like they owe the cigarette company anything, and they can perform the experiment without any bias. So sometime this year you're going to be asked to gather information from online, and you've got to make sure that you're not getting biased information, that you're getting factual information. So one of the things I need you to know, and to be successful in this school year, don't just memorize the scientific facts and ideas. I don't want you to memorize this chapter. I don't want you to memorize the terms. You do have to memorize the terms, but I don't want you to just memorize. You have to understand. You have to be able to apply, and you need to be able to connect. When you take my tests, you're going to have application questions. You're going to have understanding concept questions. You're going to have connections, critical thinking questions. So you want to try to see the thinking behind the experiments, and you want to try to pose the kind of questions that scientists ask. I'm going to ask you to watch this video. If you can't, then we'll watch it in class. Understand that science will help you be comfortable in a world that will keep changing, and it will help you make complex decisions that also involve cultural customs, values, and ethical standards. Your information on science that you're learning is going to help you vote in the future on your presidents. It's going to help you make decisions, personal decisions in your own lives based on your understanding. So that's important. So don't just memorize, understand, apply, critically think, and that's the way you're going to be successful. Understanding biology will help you realize that we humans can predict the consequences of our actions, and that we can take an active role in directing our future and that of our planet. And we only have one planet, so we've got to protect that planet. So we've got to be able to apply what we learn in this course this year to help protect that planet for future generations. So what the scientists do based on their understanding is they take their testing and they recommend public policies and decisions. They help citizens who vote to influence these public policies by casting ballots. You're going to be able to vote in a few years. So it's important for you to understand how science works so that you can pick the candidate who is going to help empower and move science forward rather than create the limitations on science. Okay, that's the end of section 1-2. We flew through that one really quickly. 2 screencasts. See you in section 1-3. Have a good one.